Before moving on designing and building further blocks to the theremin, let's stop for a moment to do some tuning work that, done now, would be relatively easy, but, done when the whole instrument is completed, could become much more complicated. I'm talking about the tuning of the pitch reference oscillator and the pitch variable oscillator. This tuning needs to be done in such a way that a clear audio sound is generated at the output of the mixer, and it is a very important part of the whole project. Besides, this gives also the opportunity to test the design implemented so far. If we temporarily connected the output of the mixer directly to the input of the amplification chain that goes to the loudspeaker, like this, we could actually hear the sound of the theremin even if we have not completed yet the whole volume section. In fact, we should be able to connect the pitch antenna to the pitch variable oscillator and verify that we can actually generate different notes by moving a hand in front of the pitch antenna. Let's begin. To tune the two pitch oscillators, we need to be able to measure the outputs independently. The problem is that both outputs are connected to the inputs of the mixer. So when trying to measure the frequencies of the two oscillators, we would end up attempting to do the measurement on a wave that is already a composition of those from the two oscillators, like we saw in the episode describing the mixer itself. So, to be able to measure the frequencies of the two oscillators, we need to disconnect at least one of them from the corresponding mixer input. Then, we can measure each of the two oscillator frequencies independently. To be able to connect and disconnect one of the two oscillators at will, I used a jumper in between the pitch variable oscillator and the corresponding mixer input. Once the pitch variable oscillator is disconnected from the mixer, we can connect the oscilloscope probe to each of the oscillators individually and measure their frequencies. The other thing we need to do is to have the antenna connected to the pitch variable oscillator. Otherwise, the tuning doesn't make much sense, because when attaching the antenna, the frequency of the oscillator will change. Finally, the tuning needs to be done in such a way that the frequency of the pitch reference oscillator is just above the frequency of the pitch variable oscillator, basically a difference of about 20 Hz. I'm sure you're now asking why it has to be so. Can't it be the other way around, with the pitch variable oscillator having a frequency higher than the pitch reference oscillator? Well, the answer is no, and here is why. Let's make a picture to help me explain what is going on. Let's consider an axis representing frequencies. On this axis, let's represent the frequency of the pitch reference oscillator with point A. The frequency of the pitch variable oscillator, which we are saying should be smaller, is represented by the point B. The audio frequency that is generated by the mixer is the difference of these two frequencies, or in other words, is the length of the segment BA. When we get a hand closer to the pitch antenna, we are actually increasing its capacity, and therefore the total capacity of the resonating tank of the variable oscillator. As a result, the frequency of the oscillator lowers. On the diagram, this means that the position of point B moves to the left, thus increasing the frequency of the audio signal. Remember that the audio frequency is the length of segment BA. So, moving the hand in front of the pitch antenna causes point B to move back and forth, but still remaining to the left of point A. This means that when the hand is far away from the antenna, the theremin produces low-pitch sounds, and when the hand is closer to the antenna, the theremin produces a higher pitch sound. This is exactly how we want the theremin to work. But let's explore the other case, if we had the pitch variable oscillator running at a higher frequency than the pitch reference oscillator. In this case, point B would be to the right of point A, and when the hand gets closer to the antenna, point B gets closer to point A. And it can even move to the other side of point A. So, you see what happened? we would have different position of the hand, creating the same pitch when point B is at the same distance from point A, but on opposite sides. How would you like to play an instrument where the same note is played for different position of the hand? Think of a piano that has each note doubled on the two sides of the middle C. How would you play it? So, the only chance to have the theremin working correctly is to have the pitch reference oscillator running at a frequency that is always higher than the pitch variable oscillator. And this happens only when the initial frequency of the pitch variable oscillator, when the hand is far away from the antenna, is lower than the one of the pitch reference oscillator. But how much lower? Well, it depends on the lowest pitch that you want the theremin to produce. In general, we will try to set that around 20 Hz, or more exactly, as close as possible to 22.5 Hz, which is the lowest possible audible note that can be generated by an instrument and that is audible by the human ear. Before showing you in lab how to do the tuning, it is important to note that when I tried to tune the pitch oscillators for the first time, I found that the frequency of the pitch variable oscillator was too high and that I could not lower it by just playing with the variable capacitors in the resonator. This happened because I overestimated the capacity of the pitch antenna, and so I chose a value for the capacitor in the resonator that was too low. In fact, in order to lower enough the frequency of the oscillator, I had to add an extra capacity of 200 picofarad to the resonator. I already fixed the circuit posted on eleneasy.com Theremin's page, so if you download the schematics now, you should get the correct value. Let's now move to the lab and see how the tuning is actually done. Here we are in the lab, and we are trying to tune the pitch reference oscillator and the pitch variable oscillator so we can make the theremin emits its very first sound. Here is the jumper that I talked about before. I'm going to show you what's going to happen if I try to make a read of the frequencies of the pitch variable oscillator and pitch reference oscillator without disconnecting one of the two oscillators, in particular the pitch variable oscillator. So let's turn on the theremin and let's connect the probe first to the pitch reference oscillator. Here we go. And let's take a look at the oscilloscope. What we see. Okay, so you can see that basically we are looking at a wave that has both the components and high frequency of the two oscillators and the resulting audio. But this is not what we want. We want to be able to measure the two waves independently so we can fix the frequencies of each one of them and set them the way we need. In other words, we set them 20 Hz apart, where the pitch variable oscillator is lower than the pitch reference oscillator. So let's disconnect the jumper, which connects the pitch variable oscillator with the mixer. And now let's take a look again at the signal on the oscilloscope. Okay, so now we can see the clear wave of the pitch reference oscillator, which right now is oscillating 171.114 kHz. Let's see what is the range of the pitch resonant oscillator while we try to modify the value of the variable capacitors. So basically we are going to modify these two capacitors and see how the frequency of this oscillator changes. So let's concentrate on that for now. You can see the frequency, which is right now here, 171.103 or 104 kHz. Let me change the first capacitor. So I'm going up right now. Okay, this is the top frequency with the first capacitor. Let me change now the other variable capacitor. Let's see where we can go. So it looks like the better we can get is 175.3 or 305 Hertz. And the minimum instead, let's change capacitors in the other direction now. This is about the minimum with the first variable capacitor. Let's adjust the other one now. Okay, so it's about 167 kilohertz. So basically we can go from around 167 kilohertz to 174 kilohertz with the pitch reference oscillator. Let's do the same now with the pitch variable oscillator, so we can compare them and we can decide how to set them up. So for the pitch variable oscillator, the output is right here, and the reading right now for that oscillator is 170.7 kilohertz. So let me change now the capacitors of the pitch variable oscillator, which are these ones hidden over here. There are two of them. Okay, now you can see them both. The other one was underneath the probe. So let me put the probe this way so we can see both of them here. So now I'm gonna change those two, and let's see what is the range of frequencies for this oscillator. So let's go with the first variable capacitor. Let's try to go down first. Okay, I think this is the minimum for the capacitor. Let's go with the other one now. Okay, I guess this is the minimum. So the minimum for this oscillator is 166.5 kilohertz. Let's go find out what is the upper side of the range. So let's move now the capacitors in the other direction. This is the best I can do with that capacitor. Now the other one. Okay, I guess we can play around 169 kilohertz with the pitch variable oscillator. So what I'm gonna do is to go back to the pitch variable oscillator now and set it to 170 kilohertz. And then from there we will adjust the pitch variable oscillator a little lower than that, about 20 Hz lower, and then at that point we should have the minimum possible frequency of the Theremin, which is about 20 Hz. So let's see. Right now the pitch variable oscillator is running at 166, so we said we have to go up to 169. So let's try to do that. Okay. Remember what we said, the capacity of a person may influence the way the Theremin works. So even if we do the tuning this way right now, we still have something to play about with the pitch control here, which will change slightly the difference depending if we go a little left or a little right with it. So let's see, for example, right now I'm about in the middle with the potentiometer, and I'm reading 168.966. If I move the potentiometer to the left, you can see the frequency lowering a little bit. Now it's 168.818. If I move it to the opposite side, all the way, it goes to 169.52. So you can see we have a little bit to play with. Let me put it back in the center. So 168.931. So what we want to do now with the pitch variable oscillator is to go about 20 Hz below that. So about 168.910 Hz, right? So let's go back to the other oscillator. Now I have to make sure I stay far away as possible from the antenna, which is right here, as you can see. So, and it's connected to the Theremin, you see, through this cable here. So right now the frequency of the pitch variable oscillator is set to 169.95. We have to go down to 169.1, we said. So, if I recall right, did I do that? Let me check again the frequency of the pitch reference oscillator, just a sec. So let me go back over there. And this is, okay, it's 168.9. I need it just a touch higher, so I can easily adjust the other oscillator. Let me see if I can do that. Okay, 169.110. So I'm gonna change the other one to be 169.090. 169.090. So we have to go down a little bit. Okay, I think I will leave it like that, because we can still play with the potentiometer for the pitch reference oscillator to make the final adjustments. And now let's go back here to the circuit. Now what we want to do is actually reconnect the pitch variable oscillator to the mixer. There we go. So now what we want to do is temporarily connect the output of the mixer directly to the input of the audio preamplifier. So we can actually hear what we have done, and if there is actually a sound that comes out of the theremin. So the mixer output is this connector here. There we go. And we are going to connect it to the input of the preamp, which is right here. So now they are connected together. So let me try now to play here with the volume. First of all, let me try to adjust this. Let's see if we can hear anything like this. Consider that right now there is the missing VCA in between. So there is one amplifier stage missing, so the signal is very low and the amplifier will not be able to catch much of the sound, but still we should be able to hear something if we increase the volume. Let's try to adjust this a little bit, one direction and the other. Let's see if it helps. Apparently not much. So let's see, this is actually the mixer output and this one is the preamp input directly on the potentiometer. We should actually be able to hear some kind of sound. Let me disconnect this one for now. We don't need it. Oh, here it is! Look at that, the oscilloscope was causing trouble. See, I can change this a little bit. Let me see now if I can make change with antenna. Oh, I'm on the wrong side. You see? When I get closer to the antenna, the frequency lowers, so I am the wrong side of the pitch variable oscillator. I had to lower it more. So let's go back over here. Let's disconnect the audio again. Let's disconnect again the jumper. And let's reconnect the probe to the pitch variable oscillator. So ground here and output over here. No, not this one, it's this one. There we go. So let's go back over there. Apparently we have to lower it a little bit more. So let's try to go, right now it's 168.936. Let's try to go to 168.9. Let's see if we can do that. Hopefully now is good. So again, let's disconnect the probe. Let's reconnect the mixer output with the preamp input. Okay. Okay, let's see what happened out of using the antenna. Still on the wrong side. We have to lower even more the pitch variable oscillator. So let's go back here. Or we can increase the pitch variable oscillator. Let's try to do that for a change. So let's touch the probe. Let's connect it to the oscillator. Let's see what it's doing right now. 169.105. Let's see if it works. So let me disconnect the oscilloscope probe, and then let me attach again the audio. You see, this is over and over always the same thing. We have to go back and forth until we find the right place where to stay. Okay, let's see now what happened with the antenna. Ooh, we are still on the wrong side. So let me try to do this now. Without doing anything, I'm just trying to change the pitch reference oscillator. Let's see if this works. Yes! Okay, so you can see now, we get closer, becomes higher pitch and then lower pitch. You see, higher pitch, lower pitch. And if I change the brightness, so this is it. I guess we have done it. It's working correctly. Now it would be just a matter of completing the circuits with a VCA, and then everything should be fine. The VCA should be able to amplify a little bit more the signal, and it should also enable the volume antenna, and then we should have a perfectly functioning Theremin. So let's see what happens in the next episodes. Bye everybody, and happy experiments!